We are BYU student researchers and presenting a methodology for radiation testing of modern SoCs. One of the challenging aspects of doing radiation testing with a modern SoC is that it's very complex and difficult to see what component failed. And the time to test radiation SoCs is very limited. And so it's our objective to document how and when these components fail in great detail, as well as making it universal across different boards, such as a Xilinx board or an Intel board, and making it simple to use.
An SoC is an integrated circuit with many different components inside of it that it uses to fulfill a specific role. The roles that it can fulfill are dependent on the components that have been integrated into the specific kind of SoC. Because the SoCs have many different components in it, it is important to understand that with radiation testing, you have to test all of the components together. This means that if one of the components of the SoC fails, it may cause the other components to fail as well alongside of it. This might cause the board to crash and then thus stopping all data to and from the board.
Our plans were to create multiple test functions that exercise different components and run those in a round-robin fashion. Over here in Figure 4, we have the modules that we have implemented that are currently being tested, and our expectations were to find upsets or radiation-induced errors in some, if not all, of the module tests that we created. In Figure 5, we have an example setup of how we monitor the SoC, and the SoC is located down here in the Ultra 96 board.
All right, as just pointed out, there's a lot of things we do have the ability to test, and that we've done a lot of work we've done. Still work in progress, still more things to flesh out. We're hoping to make more tests. We're hoping to be able to get them to play nice with each other. Sometimes there are inadvertent effects between one another that require you to separate them in different programs. Other difficulties we're having is the fact that a lot of the SoC is designed to interface with the external world. And so to really properly test that functionality, you need to have external equipment, which just makes the whole thing more and more difficult. This is all, the work we're doing right now is in preparation for an upcoming radiation test at Los Alamos National Labs Lances facility, where we are going to be irradiating these MP-SoC chips with neutrons, which should be causing a lot of SEUs, or single event upsets. And our hope is that this methodology we have with testing all these different components and doing it all together will allow us to really monitor all these different radiation effects happening in our board. So we're really looking forward to that, and we're hoping to have some good success in the near future.